Today, we'll delve into the fascinating topic of the formation of globular clusters in the Milky Way's galactic halo, with a special focus on NGC 6723. First, let's understand what globular clusters are. Globular clusters are densely packed groups of stars, typically containing tens of thousands to millions of stars. These clusters are ancient, with ages often exceeding 10 billion years, making them some of the oldest objects in our galaxy. They orbit the Milky Way's center in its halo, the spherical region surrounding the galactic disk. Now, the formation of globular clusters is a subject of intense study and intrigue. There are several theories about how these clusters formed. One prominent theory suggests that globular clusters are the remnants of the early stages of galaxy formation. In the early universe, small, dense regions of gas could collapse under their gravity to form stars. These regions, if massive enough, could give birth to globular clusters. Another theory posits that globular clusters might have formed in dwarf galaxies that later merged with the Milky Way. As these dwarf galaxies were pulled into the Milky Way's gravitational field, their globular clusters were stripped away and incorporated into the Milky Way's halo. Let's now turn our attention to NGC 6723, a globular cluster located in the Milky Way's galactic halo. NGC 6723 is situated near the boundary of the constellations Sagittarius and Corona Australis, roughly 28,000 light-years away from us. This cluster is particularly interesting because it shows characteristics that can give us clues about the conditions of the early Milky Way. NGC 6723, like other globular clusters, consists of very old stars, some of which are more than 11 billion years old. Studying the stars in NGC 6723 helps astronomers understand the chemical composition and physical conditions of the early universe. For instance, the stars in this cluster show low metallicity, which means they contain fewer elements heavier than hydrogen and helium. This low metallicity is a signature of stars formed in the early universe, before successive generations of stars created heavier elements. Recent observations suggest that NGC 6723 might have formed in a dwarf galaxy that was later accreted by the Milky Way. This theory is supported by its orbit and the chemical composition of its stars, which differ slightly from those formed directly in the Milky Way. Such studies indicate that the Milky Way has grown, in part, by assimilating smaller galaxies and their star clusters. In conclusion, the formation of globular clusters like NGC 6723 in the Milky Way's galactic halo provides vital insights into the early stages of galaxy formation and evolution. By studying these ancient star clusters, astronomers can piece together the history of our galaxy, revealing the processes that shaped the Milky Way into the majestic spiral galaxy we see today. Thank you for your attention, and I hope you found this exploration into globular clusters as fascinating as I do.